Hi everyone, today we'll be looking at paper 2 of Pure Mathematics of the June 2018 session. Question 1, we're being given a function 2x plus 5 over x minus 3 for x greater than or equal to 5. So we need to be careful of the restriction here on the domain. Find g of 5, where it's a composite function. So g of 5. We will first need to do g of 5, which is 2 times 5 plus 5 over 5 minus 3, which is g of 15 over 2. And then we reapply g onto 15 over 2. 2 times 15 over 2 plus 5 over 15 over 2 minus 3. This is giving me 20 over 9 over 2, which is 40 over 9 for 2 marks. We then need to state the range of g. It's only worth a mark, but there is some work to be done here in order to determine the range of g, and I actually will go through the process of sketching g of x. I will start by considering y is 2x plus 5 over x minus 3 without imposing the restriction on x being greater than or equal to 5. So we can easily see that when x is 0, y will be minus 5 over 3. And also if y is 0, then the numerator must be 0. That means that x must be minus 5 over 2. So we managed to determine the cut on the axis. There is obviously an asymptote at x is 3. That's the vertical asymptote. To find the horizontal asymptote, we need to consider the behavior of y as x tends to infinity. So, as x grows infinitely large, we see that y goes to 2. You can just take your calculators and substitute in the place of x a really big value. You will see that the plus 5 and the negative 3 become insignificant as x grows larger and larger, and therefore this simplifies to 2x over x, which is just 2. So I think we've got enough information at the moment to draw a sketch of this guy. So the y-axis, the x-axis, we will just draw the asymptotes at x is 3 and y is 2. We know that we are cutting through the y-axis at a negative place and the x-axis at a negative place. So this would look like this. And the only thing we haven't really considered is the restriction on x being greater than or equal to 5. We have seen before that g of 5 was simply 15 over 2. So 15 over 2 is the value of y when x is 5, which means that we set off from this point here. So this is 5 and 15 over 2. And the graph only exists for x being greater than or equal to 5, which means it's this part here. we see that it attains a maximum of 15/2, and it progressively decreases with a minimum of 2, which is not attainable. It's the asymptote. So this simply means that the range is 2 less than g of x less than or equal to 15/2. It attains all values between 2 and 15/2, 2 not included, but 15/2 being attainable. C speaks about finding G inverse. So we will start by writing y is 2x plus 5 over x minus 3. I will interchange x and y, so wherever I see a y, I'll put an x. Wherever I see an x, I'll put a y. I will cross multiply and proceed in making y the subject. So xy minus 2y is 5 plus 3x. I will factor out the y, and this will allow me to make y the subject of the formula. Now, if I stop here, I'm actually wasting one of the marks because I need to say G inverse of x. So G inverse of x is 5 plus 3x over x minus 2. And I also need to state the domain. The domain of G inverse is simply the range of G. So I only have to say 2 less than x less than or equal to 15/2. So we found the inverse. We have to be careful because we're being asked to find the domain actually. So we just use the answer to part B. That was question 1. Question 2 is on vectors. We have to find the position vector of D using the known position vectors of points A, B, and D being a point such that AB is BD. Now, we know that AB is simply B minus A. AB is B minus A, the second letter minus the first one. So AB is 4, negative 2, 3, minus 2, 3, negative 4, which is 2 minus 5, 7. And we also know that BD will be OD minus B, which is 4, negative 2, 3. And we've been told that the two vectors are equal. So I'm just going to set this equal to 2 minus 5, 7. Which means that OD is 2 minus 5, 7 plus 4, negative 2, 3, which is 6, negative 7, 10. That's the vector, the position vector of D. And then given that the magnitude of AC is 4, for 3 marks we need to determine the value of A. Now, I will start by finding an expression in terms of this constant A for the vector AC. So AC will be A5, negative 2 minus the position vector of A, 2, 3, minus 4, which is A minus 2, 2, 2. The magnitude of AC is simply found by applying Pythagoras theorem in 3D. So it's A minus 2 squared plus 2 squared plus 2 squared, and all of these square root. And we've been told that this is equal to 4. So a minus 2 squared plus 4 plus 4 is 16. I've squared both sides, which means that a minus 2 squared is 8. So a minus 2 is plus minus the root of 8, leading to a being 2 plus minus root of 8. The question was asking for the value of a. Now, I had two values. I need to decide which one of the two to keep. If I go back to the question, I see that a has been given to be negative. So I need to pick out the negative of the two. Since a is less than 0, a is 2 minus the root of 8. And that's the end of the second question of this paper. Third one, if m and n are irrational numbers, where m is not equal to n, then mn is also irrational. We need to disprove this statement by means of a counterexample. So, how can we come up with two irrational numbers not equal to each other that give a product that is rational? So, one such example could be considering m to be root 3 and n to be minus root 3. Then both m and n are irrationals. However, mn is root 3 times minus root 3, which is negative 3, which is irrational. So this is enough for us to disprove the given statement. Bi, we need to sketch the graph of y is the modulus of x plus 3, and then explain why the modulus of x plus 3 is always greater than or equal to the modulus of x plus 3. So, in order to sketch the graph of y's modulus of x plus 3, we need to recall of exactly what the modulus function is doing. It's making positive whatever I throw into it. So if I have y is modulus of x plus 3, it will just output x plus 3 if I inputted something non-negative, and it will output minus x plus 3 if x was negative. So this is really giving me quite a few features of the graph. The graph is the union of two straight lines, one with a positive gradient and another with a negative gradient, giving the characteristic V shape to the graph. And there is a handover at 0 between the two lines, and that's exactly where the vertex is to be found. So it's worth finding the y coordinate. So when x is 0, y is 3. So if I was to sketch the graph, so that's my x-axis and the y-axis. We know that at 0, 3, we've got the vertex. We know that for positive values of x, we are going uphill. So that's it. I always like to label the individual line segments with their corresponding equations. And for the negative x's, we're going downhill. So it's going to be something like that. So this is y is minus x plus 3. So we will get 2 marks for this one, and then explain why the modulus of x plus 3 is greater than or equal to the modulus of x plus 3 for all real values of x. So what we could actually do is consider y is the modulus of x plus 3. Well, this will surely be x plus 3 if x plus 3 is positive, and it will be minus brackets x plus 3 if x plus 3 is negative. This simplifies to x plus 3 if x is greater than or equal to minus 3, and minus x minus 3 if x is less than minus 3. So now the vertex is at minus 3. So when x is minus 3, y is 0. It's quite interesting now that this second graph matches the y is x plus 3. So it's going to be something like this. Okay. And this will be minus x minus 3. So it's going to be parallel. The vertex is here at minus 3. So from the graph and only, we can see that it is indeed the case that the modulus of x plus 3 is greater than or equal to the modulus of x plus 3 for all real values of x. We need to give an explanation here in order to get full marks. Okay, so we see that for x greater than or equal to 0, the two graphs are identical. For x less than 0, the two graphs are parallel. With the modulus of x plus 3 always above the modulus of x plus 3. So this is covering all the values of x. It's a good enough one explanation to secure the full marks for this part of the question. Number 4, we have two independent parts identified with Roman numerals. We need to show that this summation of 3 plus 5r plus 2 to the r is 131,798. So it's worth identifying the first few terms of this sequence. So sum from r equals 1 up to 16 of 3 plus 5r plus 2 to the r. It's 3 plus 5 times 1 plus 2 to the 1. That's the first term. The second term will be 3 plus 5 times 2 plus 2 squared. The third term will be 3 plus 5 times 3 plus 2 to the power of 3 plus dot dot dot. So what I'm highlighting in red, you will see that they form an arithmetic sequence. And what I'm highlighting in blue, you will realize that they form a geometric sequence. So this is 8 plus 3 plus 5 times 2 is 13, plus 3 times 5 plus 5 times 3 is 18, plus dot dot dot, plus 2 to the 1 plus 2 to the 2 plus 2 to the 3 plus dot 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 dot. So this is an arithmetic sequence. We have n is 16, a is 8, d is 5. So these are the ingredients of this arithmetic sequence. And this is a geometric one with, again, 16 terms. The first term is 2, and the common ratio is also 2. If I just look at the formulae, I will get 16 over 2, 2a plus n minus 1 d, plus the other one is gonna be a 1 minus r to the n over 1 minus r. If I plug everything on the calculator, I will be getting a result of 131,798 as required. The second part now refers to a recurrence relationship. Un plus 1 is 1 over un. U1 is 2/3. So U2 is going to be 1 over U1, which turns out to be 3 over 2. U3 will be 1 over U2, which is 2 over 3. So we see that every two terms we've got the sequence repeating. So it's a periodic sequence of order 2. So when I come to sum up the first 100 terms of this sequence, I will just be having 50 pairs added up. So it's going to be 50 times U1 plus U2, which is 50 times 2/3 plus 3 over 2, which gives me a result of 325 over 3. So the key point here was to identify this repeating pattern. So every 2 we repeat, so we get 325 over 3. In question 5, we're told that the equation given here has exactly one real root, and we need to use a Newton-Raphson formula to write down the given equation. So I will start off by letting f of x be 2x cubed plus x squared minus 1. The derivative of this, f dash of x, is 6x squared plus 2x. And we do know that the recurrence formula for Newton-Raphson is xn plus 1 is xn minus f of xn over f dash of xn. So in our case, this will be xn minus 2xn cubed plus xn squared minus 1 over 6xn squared plus 2xn. I actually need to put this over the common denominator of 6xn squared plus 2xn. So I will just multiply by 6xn squared plus 2xn and simplify things. Leading to 4xn cubed plus xn squared plus 1 over 6xn squared plus 2xn as required. So that was the first part for 3 marks. And then using a starting value of 1, so x1 is 1, we need to find x2 and x3. So if I just substitute in there, x2 will be 4 times 1 cubed plus 1 squared plus 1 over 6 times 1 squared plus 2 times 1. This turns out to be 3 over 4. And if I do the same with x3, I'll be getting 2 over 3. So another 2 marks here. Explain why for this question the Newton-Raphson method cannot be used with x1 being 0 then, well, if x1 is 0, if the starting point is 0, then obviously we cannot generate the second one, the second estimate, if you want, x2. So you can also see, if you look at the first derivative expression, that at x is 0, we have a stationary point. So it can never start at stationary points. Okay? So we simply need to say that there is a stationary point at x is 0. So that was question 5 of this paper. In question 6, we're being given f of x, asked to calculate f of 2. So if we just plug in x is 2 into the expression for f of x, we get a result of 0. This is certainly telling us that x minus 2 is a factor of f of x. So when we come in the second part to write f of x as a product of two algebraic factors, all we need to do is to use long division. So minus 3x cubed plus 8x squared minus 9x plus 10. We'll divide that by x minus 2. We are always trying to match the highest order term seen on the left hand side. So it is indeed the case that the remainder turns out to be 0. So x minus 2 is a factor. And this means I can now write f of x as the product of two factors. We are then being asked to use our answer in AII to prove that there are exactly two real solutions to the given equation that involves y to the power of 6, y to the power of 4, y squared. It doesn't take long to realize that the relationship between f of x and the given equation is just x being replaced with y squared. So wherever we see an x, we have a y squared, which means that solving that equation equal to 0 is the same as solving y squared minus 2 brackets minus 3y to the power of 4 plus 2y squared minus 5 is 0. Now, we need to prove that there are exactly two real solutions to the equation. I can immediately see that from this first set of brackets, we have y squared being 2, which gives me two solutions, plus minus root 2. The other one is just a quadratic in y squared, so I could consider the discriminant. So the one I'm highlighting here in blue, I will just consider the discriminant, which is b squared minus 4ac. It's 4 minus 60, which is minus 56, less than 0, therefore no real roots. It's worth stating the obvious, i.e., there are exactly two real solutions. As required. Whenever it's a show that, it's a good idea to finish off with a conclusion, even if that means repeating what the question is actually telling you to do. And then for just a mark, we need to deduce the number of real solutions to this equation. Now, we now know that this equation that involves tan theta is just the original one f of x, with x replaced with tan theta. We know that the only two solutions will be tan theta is 2. That's the only solution. We know that theta varies between 7 pi and 10 pi. So if I just consider briefly the graph of tan theta, we know we've got asymptotes at pi over 2 and 3 pi over 2. So it looks something like this. This is 2 pi. So we've got this idea repeating. I could even extend it further and go up to 10 pi, but this will certainly take a lot of time. So we just need to consider on what's happening. So in this graph that spans from 0 to 2 pi, I could extend it for another pi just to see on what's happening in an interval of 3 pi, which is this. This is 3 pi, and this is pi. So just looking at what's happening here will certainly tell me of how many solutions I expect from 7 pi to 10 pi. So if I just draw a line at 2, I see that I have a total of 1, 2, 3 solutions, and therefore we conclude that we have 3 solutions. Considering the graph was just one way, it certainly takes longer than a minute. It's only worth a mark, but drawing the graph certainly gives us a clear view on what's happening and how many solutions we expect. Question 7. We've got two independent parts, I and II. We need to solve for x between 0 and pi over 2. For sine x is sec x. So a good idea would be to start off by writing sec x as 1 over cos x. So for sine x, cos x is 1. This is 2 times 2 sine x cos x, which will allow me to recover the double angle formula for sine. So it leads to sine 2x is a half. My PV turns out to be pi over 6. So 2x is pi over 6 plus 2 pi n, or 2x is pi minus pi over 6 plus 2 pi n. If I divide everything by 2, I get pi over 12 plus pi n, or 5 pi over 12 plus pi n. It doesn't take long to realize that the only solutions in the interval from 0 to pi over 2 are pi over 12 and 5 pi over 12. The second question, we have 5 sine theta minus 5 cos theta is 2. What we could actually do is propose that there is a way, there are values for r and alpha for which we can collapse 5 sine theta minus 5 cos theta into r sine of theta minus alpha, where alpha is an acute angle between 0 and 90 degrees. If I use the expansion here, it's r sine theta cos alpha minus r cos theta sine alpha. And if we just equate the sine theta terms and then the cos theta terms, we will be able to actually determine the values of r and alpha. So what we get is 5 is r cos alpha and 5 is r sine alpha. So 5 over r is cos alpha and 5 over r is sine alpha. So if we just draw a right angle triangle here, we put alpha, it's 5, 5, and the hypotenuse turns out to be r. So r is 5 squared plus 5 squared square root, which is 5 root 2. Tan alpha is 5 over 5. So alpha is 45 degrees. So we just managed to express 5 sine theta minus 5 cos theta as 5 root 2 sine of theta minus 45. And we know that this is equal to 2. So this means that sine of theta minus 45 is 2 over 5 root 2. The PV in this case is going to be shift sine of that, which turns out to be 60. Sorry, just a minute. If I do shift sine of 2 over 5 root 2, it's 16.4299. So theta minus 45 is 16.4299 plus 360n, or theta minus 45 is 180 minus 16.4299 plus 360n. So if I just rearrange all of these, we'll be getting 61.43 plus 360n, or it's gonna be 208.57 plus 360n. The angle varies between 0 and 360, and therefore the only solutions given to one decimal place are 61.4 and 208.6. So that was question 7. The second part was worth 5 marks, certainly challenging to determine that you need to propose the R method, the R approach, in order to collapse the sine theta and the cos theta together. 8 is a modeling question. We're looking at the trajectory of a rugby ball. The height h, capital H, is plotted against the horizontal distance x meters measured from the point where the ball was kicked. It travels in a vertical plane. We are reaching a maximum height of 12 meters and we hit the ground at a point 40 meters from where it was kicked. I think it's a good idea to actually add all this information here. This is 40. The maximum height turns out to be 12. We need to find a quadratic equation linking h with x. One approach will be for you to consider that because the graph is cutting through the x-axis at 0 and 40, it means that the factorized form should be something like x and 40 minus x. And the only thing we need to make sure is whether there is a constant here at the front. So the x and the 40 minus x are ensuring that we are cutting through the x-axis at 0 and 40. By using the symmetry, it must be the case that when x is 20, the height is 12. So when x is 20, h must be 12, which means I can substitute this in order to determine the values of k. 20k, 40 minus 20. It turns out that k is, let me just do it, 3 over 100. And therefore we have that h is 3x over 100 times 40 minus x. That was the first part. Now the ball passes over the horizontal bar of a set of rugby posts perpendicular to the path, and this is 3 meters above the ground. The bar is 3 meters above the ground. So I could actually draw the bar. It's 3 meters above ground. It could be here, or it could actually be on the other side of the graph. So this is 3 meters here. We need to use our equation to find the greatest horizontal distance of the bar from the origin. So we're actually after this second particular case. So we know that the height is 3. So when h is 3, we get that 3 is 3x over 100 times 40 minus x. So 300 is 120x minus 3x squared. I will collect everything on one side. And what we could do is use the quadratic formula for this one. It cannot be factorized. It's minus b plus minus b squared minus 4ac over 2a. And this is giving me results of 20 plus minus root of 300. We need to pick the furthest horizontal distance. So hence 20 plus root of 300, we can give this as 37.3 meters. Don't forget to include the units. C, we need to give a limitation of the model. A limitation of the model could be anything that practically will make this model not valid. So we could say that the ground is horizontal. That's a limitation. It's highly unlikely that the ground is horizontal. We have that the trajectory is a perfect parabola. That's highly unlikely. So that's another limitation. And other ideas stemming from mechanics, I guess, could be that no air resistance accounted for. So any sensible comment is pretty much acceptable here. That is indeed a limitation of the proposed model. Question 9. It's on proving from first principles the derivative of cos theta being negative sine theta. Recall that f dash of x is the limit as h tends to 0 of f of x plus h minus f of x over h. This is actually given in the formula booklet. If we just set f of theta to be cos theta, then f of theta plus h would be cos of theta plus h, which using the compound formula will be cos theta cos h minus sine theta sine h. So f of theta plus h minus f of theta over h will simply be cos theta cos h minus sine theta sine h minus cos theta and all over h. And the idea is to collect the cos theta terms together. So it's cos theta of cos h minus 1 over h minus sine theta sine h over h. This means that f dash of theta is the limit as h tends to 0 of cos theta cos h minus 1 over h, exactly what we have above, minus sine theta sine h over h. And we will be using exactly what's being provided here in the question. As h tends to 0, sine h over h goes to 1, and cos h minus 1 over h goes to 0. So this guy here goes to 0, and this guy here goes to 1. So all of these will simply be minus sine theta as required. So this is differentiation from first principles. Next question, question 10. It's a spherical mint of radius 5 millimeters placed in the molten sack. 4 minutes later, the radius is 3 millimeters. In a simple model, the rate of decrease is inversely proportional to the square of the radius. Now, the rate of decrease is dr dt is proportional to the square of the radius, inversely proportional, so 1 over r squared. So we go from a proportionality to an equation by introducing the constant of proportionality. It's minus k over r squared. The negative sign indicates the decrease. So this is a differential equation in terms of rt and this constant of proportionality k. I will solve this by separating the variables. So using cross multiplication, I collect the r terms with the r and the t terms with the t and integrate both sides. So r cubed over 3 is minus kt plus c. It's a good idea now to use the given information initially. So when t is 0, the radius is 5, so 5 cubed over 3 is 0 plus c. So this means that c is 125 over 3. And the second piece of information is that when the time is 4 minutes, when t is 4, then r is 3. So we have 3 cubed over 3 is minus 4k plus 125 over 3, which is the value of c. And this is giving me a result of minus 49 over 6. K is minus 49 over 6. So I could actually come up with r cubed over 3 is minus 49 over 6 t plus 125 over 3, we were asked to find an equation linking the radius of the mean and the time. You should define the variables that you use. We've been asked explicitly for a definition of the variables. We have to be careful. R and T are being proposed by us, so we can say that where R is the radius in millimeters and T is the time in minutes, after the meat is placed in the mouth. So we need to actually explicitly define the two variables. We don't need to make R the subject of this formula. Hence, find the total time taken for the mean to completely dissolve. Give your answers in minutes and seconds to the nearest second. So in other words, if R is 0, this means that 0 is minus 49 over 6t plus 125 over 3. So 49 over 6t is 125 over 3. So if we just solve this one, we get t to be 250 over 49, which we can convert into minutes and seconds. It's 5 minutes and 6 seconds. That's the time in minutes and the seconds to the nearest second. Suggest a suitable a limitation of the model. A limitation of the model. Well, someone could actually consider the time we obtain in B and simply say that the model is limited for times up to 5 minutes 6 seconds. Other ideas will be not considering the temperature in the mouth or any other practical explanation of why the model is limited as it's proposed in this question. Question 11 is about finding A, B, and C. I could start off by expressing everything over the same denominator of x minus 3 and 1 minus 2x in order to get rid of the denominators. So 1 plus 11x minus 6x squared is ax minus 3, 1 minus 2x plus b 1 minus 2x plus c x minus 3. I could actually pick x to be 3. And if I pick x to be 3, this will allow me to find the value of b. So I'm just substituting x is 3. On the left hand side, I get minus 20. And on the right hand side, I get minus 5b. And therefore b is 4. Another good value will be a half. So the left hand side turns out to be 5 and the right hand side turns out to be minus 5 over 2. Therefore c is negative 2. And I'm running out of good values for x. I'm just going to put x is 0 and I'll get 1 is minus 3a plus b minus 3c. I'm substituting b with 4 and c with negative 2. And I get 1 is negative 3a plus 10. So 3a is 9. So a is 3. We were only asked to find the values of a, b, and c. Don't do anything else. So a is 3, b is 4, c is negative 2. That was the first part. And then prove that this is a decreasing function. I guess the fact that we have split this down into partial fractions should be useful. So f of x is now 3 plus 4 brackets x minus 3 to the negative 1 minus 2 brackets 1 minus 2x to the negative 1. So f dash of x, the 3 goes away. For 4x minus 3 to the minus 1, it's get the power down, deduct 1 from the power times the derivative of the bracket, which is 1, and then minus 2, get the power down, deduct 1 from the bracket times the derivative of the bracket, which is minus 2. This is minus 4 over x minus 3 squared minus 4 over 1 minus 2x squared. We need to prove that it's a decreasing function. Actually, a decreasing function means that f dash of x is negative. So x minus 3 squared and 1 minus 2x squared are positive for all x greater than 3, because we have been defined f of x to hold true for x greater than 3. So if both of the denominators are always positive, then we can just say hence minus 4 over x minus 3 squared and minus 4 over 1 minus 2x squared are negative for all x greater than 3, i.e. f dash of x is less than 0, hence f of x is a decreasing function. Once more, we need to end up with f dash of x being negative and actually state that a negative derivative means that the function is decreasing. So that was question 11. Question 12 is about solving this trigonometric equation. We could actually start by considering that we can express the double angles in terms of thetas. So 1 minus cos 2 theta, left hand side. We could write this as 1 minus 2 sine square theta, which is 1 minus 1 plus 2 sine square theta, which is 2 sine square theta. We could actually look at the right hand side now, which is tan theta sine 2 theta, which is sine theta over cos theta times 2 sine theta cos theta. The cos theta cancels out and you are left with 2 sine square theta. So left hand side is 2 sine square theta, which is the right hand side, therefore shown. So that will be the first part, and then hence solve, it says, the equation sec squared x minus 5, 1 minus cos 2x is 3 tan squared sine 2x. Given in non-exact answers to 3DPs were appropriate, so this is 6 marks. We expect some answers will turn out to be exact and some others will need to be given to 3 decimal places. Somehow we need to find a way of connecting the identity we've proved in the first part. So what we could actually do is replace the 1 minus cos 2x with tan x sine 2x. So that means we could write this as sec squared x minus 5 brackets tan x sine 2x is equal to 3 tan squared sine 2x. I will collect everything on the left hand side, so sec squared x minus 5, and then in brackets tan x sine 2x minus 3 tan squared x sine 2x is 0. I will factor out tan x and sine 2x, and I will get sec squared x minus 5 minus 3 tan x. So we have tan x is 0, or sine 2x is 0, or sec squared x minus 5 minus 3 tan x is 0. I will actually use the identity of sec squared is 1 plus tan squared. So 1 plus tan squared x minus 5 minus 3 tan x is 0. This will lead to a quadratic in tan squared x minus 3 tan x minus 4 is 0, which factorizes into tan x minus 4, tan x plus 1 is 0. So we have tan x is 4, or tan x is minus 1. We are lucky enough that the range of values is just from minus pi over 2 to pi over 2. So the PV in the first one is 0. So x is just pi n. The PV for sine 2x being 0 is 0. So 2x is 2 pi n, or 2x is 2 pi n plus pi, which upon division by 2 gives me x is pi n and x is pi n plus pi over 2. For tan x being 4, I will determine the principal value. We are in a radian mode, so the principal value in this case is 1.3258, and for tan x is minus 1, the PV is minus pi over 4, with corresponding generating formulae pi n plus 1.3258 and pi n minus pi over 4. Since the values for x are between minus pi over 2 and pi over 2, and the limits are not included here, we get minus pi over 4, we get 0, we get 1.326. They want 3 dps for non-exact answers, and these are the solutions we get for this trigonometric equation. Next one, 13. We're being given the graph of a curve C with equation x ln x, and we've got the line L passing to the point P with coordinates E, and it's a normal at that point. We need to show that the exact area of R is AE squared plus B, with A and B being rational numbers to be found. So I think it's worth finding the equation of L first of all. So I will start by differentiating. We've got y is x ln x, dy dx is product rule. Differentiate the first one, keep the second, ln x, plus keep the first, differentiate the second, which is ln x plus 1. I will evaluate the y dx at e and get ln e plus 1, which is 2. Therefore, the gradient of L, being a normal, will be minus a half. So the equation of L would be y minus y1 is mx minus x1. So y minus e is minus a half x plus e over 2, leading to y is minus a half x plus 3e over 2. If you look at the graph once more, we are certainly interested in the point where the normal will cut through the x-axis, but also the point at which the curve C is cutting through the x-axis. So let's start with that. If we have a cut on the on the x-axis, this means that y is 0 and we have x ln x is 0. Either x is 0 or ln x is 0, so x is 1. If we just consider the line L cuts the x-axis, means that y is 0. So we have minus a half x plus 3e over 2 is 0, leading to x being 3e. So let me add this information on the diagram given. So this is 3e and this is 1. We could actually split this into a1 and a2. For a1, I will be using integration. For a2, it's just gonna be the base times height over 2. So for a1, I will be integrating from 1 up to e, x ln x dx. This is an integration by parts. I will put u to be ln x, dv dx to be x. So du dx is 1 over x, and v is x squared over 2. So if I apply integration by parts, this will be x squared ln x over 2 minus the integral of 1 over x times x squared over 2, which is x squared ln x over 2 minus the integral of x over 2 dx, which is of course x squared ln x over 2 minus x squared over 4. Now we'll put the limits of 1 and e. So plugging in the upper limit, it's going to be e squared ln e over 2 minus e squared over 4. And if I plug in the lower limit, it's going to be 1 squared ln 1 over 2 minus 1 squared over 4. Remember, we are looking for exact results here, so I have to be careful. This is giving me e squared over 4 plus 1 over 4. The area of the triangle now, it has a base of 3e minus e, that's the base here, and a height of e. So I will be doing base 3e minus e times height over 2. This is 2e squared over 2, which is simply e squared. So the shaded region R, which is just A1 plus A2, will be e squared over 4 plus a quarter plus e squared, which leads to the result of 5e squared over 4 plus 1 over 4, which is exactly of the form required in the question. Question 14 is a modeling question. We are studying the population of mice on an island. We've got capital N being the number of mice, and T is the months after the beginning of the study. This is the equation that gives the number of mice T months after we started the study. We need to find the initial population of mice, so we're simply going to be putting T to be 0. So when T is 0, we get capital N to be 90 for 1 mark. B, we need to show that the rate of growth dn dt is given by this expression here. I notice that they want dn dt not in terms of T, but in terms of capital N. So rather than starting differentiation straight away, I will first start off by cross multiplying. So what I will actually do is say that 3n plus 7n e to the minus 0.25t is equal to 900. And then I will use implicit differentiation. So from left to right, we differentiate 3 dn dt plus 7e to the minus 0.25t dn dt plus 7n times minus 0.25 e to the minus 0.25t is 0. And then I will try finding a way of substituting for t in order to obtain an expression for dn dt entirely in terms of n. So we have 3 dn dt plus 7e to the minus 0.25t dn dt minus 0.25 times 7e to the minus 0.25t times n is 0. So actually, by revisiting the expression for n in terms of t, maybe we could find a way of expressing 7e to the minus 0.25t in terms of n. So this is what we were originally given. So if we cross multiply, we get 3n plus 7n e to the minus 0.25t is 900. So I know that in the place of 7e to the minus 0.25t times n, I could put 900 minus 3n. And in the place of 7e to the minus 0.25t, I could put 900 minus 3n and all of it over n. So this is giving me 3 dn dt plus 900 minus 3n over n dn dt minus 0.25 times 900 minus 3n is 0. I will multiply everything by 4n. So this will make this 1. So multiply everything by 4n. So this will give me 12n dn dt plus 4 times 900 minus 3n dn dt minus n 900 minus 3n is 0. So I could actually proceed. I have 12n dn dt plus 3600 minus 12n dn dt is n brackets 900 minus 3n It's easy to see that the 12 NDNDT with the 12 NDNDT go away. So we get 3600 dNdt is equal to 3 and 300 minus n. I just factor out the 3. The 3600 with the 3 leaves me with 1200. And therefore dNdt is n 300 minus n over 1200 as required. So that was part B for 4 marks. We are then being told that the rate of growth is a maximum, not the growth, the rate of growth. The rate of growth is a maximum. This means that we have that d2n by dt squared must be 0. Because if the growth was a maximum, dn dt would have been 0. Now it's the rate of growth, so it's the second derivative that must be 0. Now, I will not use differentiation. I will just consider what is dn dt if I expand it. So dn dt is 300n over 1200 minus n squared over 1200, and this is actually a quadratic which is symmetric about minus b over 2a. So if you have a quadratic ax squared plus bx plus c, then it's symmetric at x is minus b over 2a, and in our case it's symmetric about n is minus b is minus 300 over 1200 over 2a, which is 2 times minus 1 over 1200. So if we just do this calculation, we get an answer of 150. So when n, capital N, is 150, the rate of growth is a maximum. The rate of growth is a maximum. So we need to find the value of t for which the rate of growth is a maximum. So we need to find t is capital T when n is 150. So we just say 150 is 900 over 3 plus 7e to the minus 0.25 capital T. Now the 150 with the 900 leaves me with a 6. So we get that 3 plus 7e to the minus 0.25 capital T is 6. So e to the minus 0.25 capital T is 3 over 7. I will take a length minus 0.25 capital T is a length of 3 over 7. So if I multiply both sides by negative 4, I get T is minus 4 ln of 3 over 7. It's the value of t. They do not specify whether we need to give this as exact or not. So if we are interested in converting that into months, it's gonna be 3.4 months. So we had to consider that it's the second derivative that had to be 0 or just the first derivative being a maximum. So we just considered the symmetry in order to proceed. Now in D, according to the model, the maximum number of mice on the island is P. State the value of P. Well, that's just calling for a consideration of the behavior of n as t goes to infinity. So as t goes to infinity, e to the minus 0.25 t goes to 0. So n is going towards 900 over 3, which is 300. Therefore, capital P is 300. That's the limiting population for this particular model. So this is what we get here. So that was the question paper, paper 2, QR paper of the June 2018 series. Thank you very much.